and security testing with CI and CD automation service. Round of applause.
All right, so as you stated, we're going to be talking DevSecOps, specifically doing security testing with automation servers, your Jenkins, your Team Cities, your Team Foundation servers. I'm Ed Arnold. I'm a solution architect and subject matter expert in the web application scanning product for Qualys, but I'm going to try to keep the Qualys talk low. So we're going to cover a little on DevOps, what it is, the challenges faced by that new development style when it comes to security, and then how to get ourselves right back into that process. Are any of you doing this currently? Firing off scans from build service a little bit? Got one hand, all right. All right, so some basics. First, a little, if anyone's playing some buzzword bingo, you're going to hear shift left, configuration as code, the push left, all these things when it comes to DevSecOps. Essentially, it just means we're kind of putting more of the onus of security testing right onto the developers. So CICD, continuous integration, continuous delivery. So basically in those systems you're going to be committing code daily and building frequently. That might be nightly builds, that might be, in the case of some of the internet service providers, they're pushing live on the fly. Some of the servers you see, they have these types, be Jenkins, Team City, Bamboo is becoming very popular, kind of might be taking over Jenkins. Circle CI, Octopus is a deployment server that I just ran into recently. But another system that you could kick off scans from once on deploy. So again, it's a much faster development cycle than your waterfalls or your agiles. So with that, security needs to be faster, security needs to be continuous. A lot of developers seem to prefer it. It's getting spread out over the industry. I believe that's just that they have more control over processes. They're controlling the application code, they're controlling the server, so you don't have the situations anymore where it works on my system, when you deploy it, why doesn't it work anymore? They're really firing these things out with their own builds, frequently with things like Docker and containers. So my demo is actually going to cover doing it in Docker as well. It really requires integrations between system and software. Everything's happening so fast. If you don't have those integrations and you're trying to inject manual processes in there, you're going to be seen as a roadblock. There's just no way around it. Relies heavily on automation, so heavily that there's a meme about it. You know it's becoming a big thing when we have an automate all the things meme. So what's the result of all this development? Well, we're getting APIs and applications everywhere. We're getting microservices, they're getting spun up. You have things in the cloud, you have things locally hosted, you have things in your internal network. You got APIs, REST APIs everywhere. It's getting a little unwieldy to manage all of those different places. So that leads us into the challenges. Some of the challenges we're facing. Another buzzword, digital transformation, you see everywhere. I thought we've been doing that for a while, but that's big this year. Software is being written at a breakneck pace. The code is just getting written and pushed live in some cases. Like I said, understanding what you have is getting difficult. You have different silos inside your organization. They have different Amazon clouds or different Azure clouds or Google clouds. They're pushing up code. They're running things everywhere. So understanding what you have is important. And all of those applications need some level of testing. So in this case, maybe we're not going to need to know about them necessarily, but we're ensuring they get tested and they show up on our dashboard or in our metrics. And if you're going to try to manually test all of those different applications, that's going to get really costly and it's not scalable at all. You're going to need a gigantic security team to be able to handle all of those different applications. So based on that, your traditional processes aren't going to work. You're constantly going to be behind on security assessments, and you'll have releases go out without security checks. That's just not, you're going to be in the way of the business, especially if you're in a consumer business. Those apps or those new promotions are going to go out whether you like it or not. And currently, in most organizations, app developers aren't incentivized for security. They need to meet their deliverables, they need to get out by a release date, but whether there's a flaw in there or not, they're not really held accountable for. So some of this involves training developers, and we'll get into that. So like I said, if we're doing the traditional processes in a DevOps architecture, we're going to be seen as roadblocks. You can't tell them, great, you built your code in a day, you're ready to deploy, but let me get you on the pen testing schedule, and in 3 weeks, we'll go ahead and test that app. That doesn't work. You're always going to be behind. So we really need to be partners with developer organizations as security professionals when it comes to this, and interdepartmental communication really needs to improve. Once again, speaking of those silos, it just doesn't work. You have to get out there and meet your devs and have some face time. You're probably going to end up having to train them a little on what some vulnerabilities are and how to remediate those, and get into some secure development. But that definitely has to improve. You can't stay in the security department and run a DevOps pipeline. So speaking of that, it's a bit of a culture change. It is a new way of doing things, and you may have some roles change. Some security departments may become more metrics driven and may be doing less testing. Or maybe your people running automated scanners right now can develop their skills and become a red team, and to do some more advanced testing. And in this case, usually not much for team building activities, but I've seen this actually be important. Bring beer. Developers seem to like that. But hold the brown bags, hold the little after work beer sessions to run over some of these, to do some of this training in a non-confrontational way. Terrific. So I want to talk a little about the development and the training, and it's a different top 10 list from OWASP. A lot of you are familiar with the OWASP top 10, which is the vulnerabilities. This is the OWASP proactive controls. This is the OWASP top 10 for developers. The first item, caveat, in 2016, the 2018, this is no longer the top item, but that doesn't work for my presentation. So 2016, verify security early and often. That means you need to be testing. You need to be testing early, you need to be testing often, you need to be in that build process. Find the vulnerabilities before the build happens, before it's deployed. There are some other items in there. A lot of these stayed the same in the 2018 list, but some of that is going to be kind of static code looking, but some of it for dynamic. Validate all inputs. You're going to need dynamic testing for that, and I am mostly covering dynamic testing here, just FYI. But it's very important. If you're not familiar with this list, you can get the 2018, it's fine. But make sure your developers know about this, because the rules are fairly basic and can obviously encompass a lot, but these are important to be in developers' minds. So parameterize your queries, encode your data, have auth controls, have access control. They need to be thinking about these things. So one says, security testing should be an integral part of your software engineering practice. I agree, it should be. So that's why we're working towards this, to get ourselves in a little earlier. But how do you do that? Do you do dynamic testing, static testing, manual testing? Whose responsibility? We can have the QA department do it because they're already doing some automated testing, some Selenium testing maybe. Security team going to do it? Are you going to automate your scans via an API? You should. And you're going to integrate yourselves right into that process. So we're going to get into the actual automation of these scans. So our goals with automating the scans into a build server are to integrate with the system, obviously, to increase your security coverage without increasing your staffing. You need to have these scans performed, but with the rate applications are being built today, you just can't have that many application testers. We also want to reduce the time to remediate. That seems to be the biggest problem in a lot of organizations that are scanning and performing these kinds of testing, is it's being tested, but no one's actually fixing it. When you insert yourself into a build process, you can make it so the build fails until the security vulnerabilities are fixed. So that's definitely going to make life easier for security teams when it comes to tracking people down and remediating and making sure all your assets have been scanned or tested at least quarterly, whatever you're trying to do. So again, DevOps and the opportunities we get. Once again, you can connect with the developers. You can become more of one team. Teach them the best practices. Teach them the things that they need to do before they build the application. For your security team, you get less time clicking buttons and scanning, which usually they're big fans of. Odds are they got into security to do some cool stuff, and clicking go on an automated scanner is not that fun. But so they can move into some red versus blue exercises, maybe some goal-oriented pen tests, trying to get the keys to the kingdom, trying to get a specific piece of data out or exfiltrated. But again, they can focus on remediation. Finding vulnerabilities is the easy part. Tracking down folks to get them to fix the vulnerabilities is really the hard part. So like I said, in this case, we're going to put that onus right on the developer while they're building. So one of the ways to do that is with the self-service model. The development teams are going to take responsibility for scanning. You're going to, once again, automate that. They're not going to be clicking buttons. They're not going to be logging into some UI or to some desktop application. Security team can administer the program. They're really going to be focused on training those developers to what the results mean and maybe how to fix that with some secure coding practices. They're going to look at trending, program effectiveness, whether those systems are being used. It's also going to help you get inventory as those scans populate your dashboard. You're going to see you probably have a lot more out there than you think. Once again, they're free to do more manual testing or something fun. And another thing is when you hold these sessions, you're going to identify your security-minded developers and kind of your security champions, and you're going to want to leverage them across to push down their dev organizations. And while I'm focused on dynamic here, this system really does fit well for static code analysis and component lifecycle management. I'm not going to cover it here, but I've seen the same thing done with Fortify, Checkmarks, Sonatype, Black Duck. These other systems really fit well into this as well. So how does it look? Developers are going to check in to some sort of source control. In this case, we have Jenkins. Jenkins is going to see that change or that code, or they'll manually inform them that there's new code. Jenkins is going to go ahead and deploy, if you have it set that way, maybe to any of these environments, staging, test, dev. Jenkins is going to make a call to, in our case, the Qualys API, but your provider's API, as long as they have one. That's going to contact some sort of scanning appliance that's going to scan, return, and all flow back and forth. So selecting a tool. Obviously, Qualys can do this, but when you're selecting a tool to integrate into the DevOps process, these are kind of the items you're going to want to look for, specifically the red highlighted ones. You're going to want scheduled scanning for systems once they're already deployed. You probably want to scan them even, do you think the vulnerabilities have been fixed? New ones come out. You want on-demand scanning, certainly, for these builds to be scanned when you want them to be scanned. You need a robust API. We'll get into why that is. And you're going to want integration with CICD servers, either via writing scripts for that API or plugins. Of course, being able to test REST APIs is very important nowadays. Being able to adapt to your Angulars and Nodes and new development styles and platforms. You want to be able to support authentication, get increased coverage. So how do we accomplish this? Like I said, some providers are going to go ahead and provide plugins or add-ons for your build system. Qualys recently released a Jenkins plugin. And you're going to need a lot of people. You're going to need top-level buy-in for this. Getting developers to change their pipeline might be a little iffy. It works the way it works now, but if they already have other security tools like a static code scanner integrated, it's going to be a much easier sell. But you will need top-level push down on that, and you're going to need to do some training. Developers aren't security professionals, and they don't need to be security professionals. They just need to know how to code securely. So showing them some examples or having a knowledge base in your organization with best practices and with code samples is a great way to do that. So, quick 2-slide Qualys plug here. Qualys did release a Jenkins plugin. If you're familiar with Jenkins, this is the pipeline script generator. So what our plugin does is it takes your credentials and your API URL, your web application ID. So this application does already need to be created inside the Qualys platform, but with automating with a script, you could create it on the fly and not have to know what it is already, which is why we're only covering this briefly. You pick your settings. It's going to generate the pipeline script for you, which is going to go ahead and look something like this. So this Jenkins pipeline is going to grab some code from GitHub. It's going to build it in Docker. It's going to run that Docker container, and then it's going to launch a scan against it. And this is the part that comes out of the Qualys plugin, with the additional step of obscuring my credentials in Jenkins. So the plugins kind of work. Like I said, in our case, for our plugin in the first version, you need the app already created. The security team's going to go ahead and have to create that. But probably a better way to do this is with a script. So what's our script going to do in this case? You're going to start your build. My script is going to query the API for the project name in the build system, so it's using the variable. Nothing's hard-coded. If it finds it, it's going to launch a scan on it. If not, it's going to create it and then return the ID and then launch the scan. It's going to sit there and poll for completion every 4 minutes. Once the scan's complete, it's going to parse the results, and if any high severity vulnerabilities are detected, it's going to fail the build, and if no high severity vulnerabilities are detected, the build's going to succeed. So let's take a look at what that does. We're going to see if this works. I did not make my sacrifices to the demo gods, so we're going video. So this is the script I'm running. My Python coding is not great, so please don't bash me for that. It does work, however, and it's pretty short for doing all that it's doing. Shout out to the people who make requests, and the new polling library is really nice when you can write a one-line polling feature. So, like I said, it's going to look for the name, it's going to launch a scan, it's going to poll for completion, it's going to parse the results. I'm going to do Jenkins and TeamCity. This is the TeamCity one. The only thing that's different is the variable for the project name. Everything else is identical. So you can essentially take scripts and move them between. The application I'm using, this is the code. It's out there. It's just a Flask application in Python with one cross-site scripting vulnerability in it. Take a look at the Jenkins configuration here. So this is a Jenkins freestyle project, not a pipeline project. So I'm pulling my code, very similar to that pipeline script we saw. I have my credentials obscured. Doing a Docker build on what it pulls down. I'm deleting any old container, and then I'm running that new container on port 80. And then I have this block of script as a shell commands stuck in here. And you can do this with pretty much all the build systems. So we'll go ahead and fire off a build on that. You can take a look at the console output. It's going to show it grabbed all my code and it's building my Docker file, or building my container off my Docker file. And it's sitting there on the last step. It's launched its scan and it's polling at that point. TeamCity is fairly similar. More steps to get to the build settings, but once you get there, you can see it's very similar. The code is kind of put at the top level, so you don't see the call for code, but you have a Docker build, a Docker run, and then the same script again. Like I said, the only difference is that variable for pulling the project name from the system. So we're going to go ahead and run that one as well. I'm going to click the wrong button. Ignore that. You can look at the build log here. Don't need to click step 2 because that's launching the container. Step 3 will appear shortly. There it is. And that's the scan launching. And again, it's just going to sit there and poll while the scans are running. We're going to look at the Qualys UI. We see the two scans, the scan submitted from Jenkins and the scan submitted from TeamCity, and they're running. Should have left that longer. This is when your developers tell you it's building. So it's building. It's building. It's building. This is cats who don't know how to cat, if anyone wants to watch it later. This is what they always tell you, right? It's building. Why your developer's doing nothing? It's compiling. It's building. We're watching YouTube videos. All right. Our build should be up. Look at that guy go. And of course he's got an itch. All right. Our builds are done. We're going to go ahead and check the results of our builds. Our scans are finished. What do we see in our build log? High severity vulnerability detected. You got cross-site scripting. The build has been marked as a failure. So that dev's not going to be happy. They're building the same app. Here we see the step is turned red because it failed, and the same thing. High severity vulnerabilities detected. So a developer is going to have to go ahead and, well, if they know how, probably verify the vulnerability. This is the app. It just simply reflects the data you give it. We do a quick little test. Oh, we're vulnerable. Can't have that. Can't release an app that looks like that. So we're going to go back to our code and we're going to fix that. Like I said, this is a Flask application. If you're familiar with Flask, you have to make it vulnerable. It won't do this by default. So I'm removing the code that made it vulnerable on purpose. Not how they would really fix it, but that's my fix. They're going to get their change. They're going to push it to your Bitbucket or your GitHub or your whatever you're using. Push that up. Now you could have your build servers detect that change automatically. I was trying to limit the amount of traffic, so neither of mine are polling GitHub to see if the code is changing. Once it changed, we're going to go ahead and build this one again, and we'll build the other one again. But Flask is robust. I'm running 2 vulnerability scans against the same app at the same time, and it works fine. So it's building again, sorry. And now we wait. Should have had some fun music with this, I apologize. Building, building, building. And there you go. Oh, don't put a cat in a sweater. All right, let's check those builds again. Ooh, no high severity vulnerabilities detected. Build succeeded. That's what we want to see. And again, another successful build because the vulnerability has been remediated. At no point did the security team step in. They ran their scan, they saw their vulnerability, they fixed their vulnerability, they rebuilt, and success. Thank you, iMovie. All right, so like I said, that was kind of hard-coded to use Qualys's information, but so like I said, one of the things that could be improved, we could create the application without previous setup, without someone from the team setting up the scan. You could also abstract the services with a custom API. I'm directly calling the Qualys API, but a nice way to do this is to write your own API, like in Flask or something that's easy to write APIs and fast. Kind of to make the vendor APIs easier to interact with, you could hard code some of the items in your API, so they only have to request the build, maybe not some of the other information. You can also switch backend providers without changing the script in that case. If you're using one vendor and you want to switch to another, you change your API in the backend. You don't have to enter the developer's build system again. I've seen that work a few places quite well. Also, I've seen work really well. It's for some of that other administrative items that's still going to be left over for your security team. If you're using Slack bots are awesome. You can say things like to a bot, give me an access token, give this user permission to this app, and you can write, once again, with a robust API, you can handle all of those things either with a bot, a script. You can automate all of this out of the security team's hands. Yeah. So mine was fast because they originally offered us 20 or 50-minute slots. So that's it. I have plenty of time for questions if anyone has any. Anyone? Sure. Shoot. You're doing it somewhat, right? Here. Yes. In our case, our appliance can sit internally, but it's still going to talk to our platform. No. Depends on what you mean by do mobile. We can handle APIs and backends. We as a company don't do static code analysis. So we don't deal with your source code. We deal with your compiled code, essentially. your apps that are running. I hear a lot of the things with the source code. I don't know. Most people just end up biting the bullet and sending it somewhere. Yeah, it's tough. I mean, you can have obviously local scanners doing static code, not have to deal with it. Fortify does it. That's the one I used to work for Fortify for 5 years. So I've done the same thing to run Fortify static code scanning against applications during build process. So that you can keep fairly in-house. In our case, we had our scanners in Amazon in our private cloud, so it was still going somewhere, but somewhere we controlled. But just you need it for this kind of system. You're going to have so many builds coming in from so many places that having to stick appliances everywhere in every different section and having to do kind of all this is just, it's going to be really hard unless you have some scanners sitting behind load balancers and things like that. So Amazon was a really nice place for us to be able to do that, to just set a pool of scanners behind one address and let it just get assigned based on who has open space to run something. So yeah, you definitely want something like that. Do that. Go ahead.
How do you handle time scaling in terms of...
Thank you.
Yeah.
I should have brought that up. So yeah, developers are not going to be happy about lots of time getting added to their build. So I think when you're doing these things, you probably want to look for kind of OWASP top 10-y items. You probably want to, the security team's going to have to probably do a little configuration. In our case, it's called an option profile. It's just the scan settings. You're probably going to want to have someone knowledgeable in web application scanning tune your scans for you. Not per application, but just some things like header injection and cookie tests take an awful long time. If you're using standard libraries in your organization, don't test them. Take them right out. Test your input validation. Most importantly, I would say. You can look for obviously some other items, but I'm using an OWASP top 10 policy with Qualys, and on that app, which has a whopping 3 links and 2 inputs, takes about 3 minutes. But yeah, that's definitely a trade-off you're going to want to pay attention to. Developers don't want to click build, and they're used to their build taking a minute and a half, and it takes an hour and a half.
Yeah, especially if you're doing 12 to 15 releases a day.
Oh yeah, obviously. In that case, I probably, if you're doing that many releases a day, I would probably do it on a different cadence. I probably wouldn't do every build. Let's say use your other tools to look at that code. I might static scan them on that depending on how fast your static scanner is. But that could add even more time. All right. Anyone else? Well, I guess you guys get a lot of time back. So, apologies. But I hope you learned something. All right, thank you.